Okay, so this is our project for Capstone. It's called Game of Zones, and our team name is Runner. And this is our group member Adam, and my name is Ye. And there are the two Michaels, Michael Rinsford and Michael Scott. And we would like to first thank you to our sponsor, CJ, and he got the master's in management and a PhD in marketing and strategy, and he's managing director at the Propel Ventures, and he taught digital media and entrepreneurship, and he authored academic papers and articles. And here's our team build, and start with Michael Scott.
I'm Michael Scott. I'm a computer science senior, and I'm the project manager.
I'm Adam Sink, CS senior, Python programmer.
I'm Michael Rainsford. I'm a CS senior, and I'm a front-end developer.
My name is Ye Wong, and I am a CS senior and back-end developer.
For our app, Game of Zones, it's going to be an application based on the web. We're going to have hardware that will read energy consumption through electricity and through emissions of cars. It'll track that information and it'll send it up to a server automatically whenever you're connected. It'll allow users to go on and view that data to see how they've consumed their energy and review everything that they've done through the day, see heat maps of when they're using the most energy and how they could possibly be more efficient. They will be able to form teams, and they'll be able to communicate, compete with their communities to see who can save the most energy and be the most efficient. There will be communication between the teams so they can share tips and tricks on how to save more energy, possibly how to make driving to work better, if they can carpool with each other and save energy between 2 or 3 people on the same team. And eventually we'll be able to scale it to larger businesses, so Joann's Fabric or JCPenney can have their energy consumption posted up and compete against each other.
So that's what we already have from our sponsor. Our sponsor gave us the user profiles already, and he got us the registration of profile to the database already, and the initial database setup is already being done. And shared data between users is already getting from the tricks or tips Michael just mentioned on previous slide.
So what we're going to be implementing is currently we have a prototype plan which includes the basic hardware connectivity. So something like you're going to want to be able to track through your SRP box. You're going to want to have how much energy is your air conditioner using, how much energy are your lights using, basic things, microwave, any household appliance really, and also your car emissions. And we want to get this done through a web platform interface. So something that you can get on your laptop, just like go to the website, see how much energy you're using. We also want a basic gamification of this information. So we don't just want the standard database. We want something that's really pleasing to look at. We want leaderboards, something that users can see, how they rank up compared to other people. Maybe oh, I'm the the top 20% of users who are reducing their consumption. You're going to have milestones and badges. So say if you're not very good at managing your consumption, you maybe have a bronze badge and you want to upgrade that to a silver or a gold. And you're also going to get notifications. So say you have a day where you do really well, you turned off your lights when you're not using them, you didn't drive 4 laps around your house, you're real good about not being too wasteful. You're going to get a notification say, hey, today's been your best day of the month, good job, congratulations. Stuff that users are going to really be motivated about reducing their consumption. And so what we're going to be having to learn for this project, we're going to have to learn a lot of front-end development. That includes PHP, JavaScript, HTML, CSS, among other things. The back end is going to be primarily done through PHP and SQL. And for the app development itself, we're going to have to learn iOS and Android because mobile development and users are going to want to interact with this software on their mobile phones. Not everyone wants to be able to well, they don't want to have to go on their desktop to look up how much energy they save. They want to be able to just take out their phone. It's really simple. Communication is a lot easier through your phone than having to, go to desktop. So we're going to definitely have to take a heavy look at app development and hardware integration, of course. So the purpose primarily is, in the United States specifically, we actually use the most energy per capita. As you can see by this graph, the US and China are actually the two most extensive energy consumption. And as you can see, the US obviously has a much lower population than China. So we use about 5 times as much energy per person that they use in China. And so obviously, when you're consuming all this energy, you have to produce the energy to consume, and that results in a lot of pollution, which can lead to reduced air quality. You endanger local wildlife. You have to build factories. You have to build power plants, dams, nuclear power plants, and all these things can be hazardous to the environment and can be very costly. And so, of course, it is a very useful thing to reduce the environmental consumption. So the intended impact is, first of all, energy consumption has no easy fix. It's very hard to just say, we will use half the energy. So the primary goal of this is to bring awareness to the issue so that users can see how much energy they're using. And through the easy access to these metrics, they'll actually be a lot more motivated to make changes. So for example, you leave your lights on when you leave the house. You don't really notice how big of a deal that is. No one's saying, oh, well, that's, every hour your lights are on is $1 to your electric bill. Like, you don't know that. You maybe get your electric bill at the end of the month, and you go, oh, it was like $10 more than last month. I don't know why. And so live metric updates will actually be very beneficial because users will be able to see, oh, hey, today I actually used twice as much energy as yesterday. Why was that? Oh, well, maybe it's, I left the blender on and I had the microwave going and I was taking a shower while the stove was running and, and I used all this energy. So we think live metrics will be very critical to actually getting people to change. And this is obviously going to be enhanced through goals and rewards based on lower consumption benchmarks. And when you have the game aspect of hey, you got a silver badge, you're doing pretty good. You maybe get that up to a gold badge. It's definitely something that people are going to take interest in. They're going to be a lot more motivated to get about doing it than when they have no metrics to even look at. So we feel like the game aspect is very critical because, one, it gives incentives to following the metrics, especially if there's rewards in it. Maybe, if you've had, your best month of the year, maybe you get you can get discounts, you can get, maybe there'll be other companies involved, sponsors like, hey, maybe SRP could give you some sort of sponsorship if if people are not wasting energy, they'll get reduced. Obviously, you're going to have a lower electric bill, but you can also get other rewards implemented through that. Obviously, we haven't communicated through to those companies yet, but that's something we do hope to implement later on. Also, a game is important because you want something that's appealing for the user to look at. A dashboard where you just go online and you go, energyexpenditures.com, and you go, oh, I used 4,800 milliwatts. What do you do? It isn't something that's fun to interact with. So we think a game where you can see, I can look at my neighbor who I know is playing, and I go, oh, well, my neighbor, they've got a bronze medal and I've got a silver medal. I'm feeling pretty good about myself. Maybe I'll go over to my neighbor's house and be like, oh, that bronze isn't looking too good. Maybe you should turn your lights off. So we think that the spirit of competition and the ability to compare your consumption with friends is going to be something that really motivates users to save energy and use our product.
So we have considered multiple methodologies for how to implement this app, this game. We have considered focus on app-based methodology, where we focus more on the app than on the web platform. We've considered a web-based methodology where we focus on the web interface instead of so much on the app interface, so it'd be primarily web-based with an app. And we've also considered making it performance-based to optimize performance. So the first methodology we've considered is mobile app-focused methodology. Most users use mobile devices constantly. It's always in their hand or in their pocket. They use it for everything from email to texting to Facebook and Twitter, obviously, Instagram and Pinterest and all these social media sites. People are constantly on their phones. So this would give them easy access to this game so they could constantly use it and see it. The possible issue with this would be that there could be more compatibility issues between different platforms and Internet of Things devices. We'd have to program it to work with iPhone and iPod and maybe not iPod and Android, various versions of each, along with making sure it works with Internet of Things devices. So the iPhone could work with the Internet of Things device, but an Android phone might not work so well with it. So you'd have to make sure that works. We'd also have to make sure that the app is compatible with like the website and all these different languages we can program it in. So there are a lot more compatibility issues. However, we've also considered a web app-based methodology. This would provide universal, unified access for all users. So it's just one perfect code base to rule them all to work with all users. And we would focus more on making a good website, which is more of a single unified platform. We'd only have to focus on one code base instead of customizing it for each phone, for each device, for each version of Android or iOS. But the theoretical issue with this would be that it's not as easily accessed. Not everyone has good 3G or 4G coverage or good Wi-Fi or data plans. So they might not be able to access it from their phone as easily. And if the app is just more of a backup, then they'd be a little more locked out of the game. So access would be an issue with this, possibly. The third methodology we've considered is more of a focus on performance. So we would make it work for an app, make it work for a website, but we'd make sure that it works really well. We'd make sure that it loads and runs quickly. We'd review the code to make sure we aren't wasting time with infinite for loops and excessive database queries. We could reduce interactivity, which makes the website not look as good, but it would increase the speed of the website. And most users don't want to wait a long time for a website or an app to load. So we could reduce animation and interaction to increase the app speed and the website speed. We could also optimize by platform. For instance, a web browser usually has a lot more support for processing power than a phone does, because it has a lot more space to store RAM and various hardware components. So we could also optimize for different mobile platforms. So one thing that Android is good at, we could optimize for that, and for iOS, we could optimize for what it's good at for their apps. So we have chosen to go with a performance-based methodology. We would focus on performance and keep in mind web limitations and what mobile users would have to sacrifice for web limitations, what other limitations phones have. We would spend a lot of time making sure that this program, this web app, this phone app, would work well with whatever hardware it's using, as previously mentioned. So we could, if there's more RAM in a computer, we could let it use more RAM to do more animation or interactivity. If a phone has like a GPS, we could make it work better with GPSs on phones, and we would just put a lot of effort into making sure our API is good and fast. Obviously, we make this software infinite or more efficient, like not having infinite for loops. And another thing we need to keep in mind is we can't drain the battery or mobile data of mobile devices. So we make it power efficient too, and not do as much querying on phone to the database. we also have to make sure that it's not constantly pulling the Internet of Things devices so that we don't drain those batteries.
So for our development model, we chose iterative and incremental, and that allows us to produce prototypes quickly. We can make changes, which is what we would need to do for this project, is to get it out there and see how it'll interact with other users and see how it flows. We would need to integrate the hardware whenever it's available because we don't have it yet. So this allows us to section it off, and we can leave the hardware section to be implemented later and have a mobile app and a web app done and able to assume data from it and then integrate it later. It also allows for scalability to larger companies, so we can have the consumer app done and then start integrating larger data values, more Internet of Things devices, and see how that reacts with the rest of it and make sure it's all flowing still the same way as it did for residential users. And it encourages communications and changes, so we can get a prototype out and see how it reacts to the user base, see what they like, what they don't like, and make edits all the way through, as opposed to leaving the whole thing to the very end and something is dissatisfying and we have to make a huge update afterwards to fix all of it.
And here's our timeline for our workflow. So since September 3rd to September 21st, we were working on signing up for teams and assigning the project that we want. And from September 25th to October 3rd, we were giving the actual project and trying to contact with our sponsor to get confirmation, and we exchange our information like our group members and contact info. And then after the instructions are being given, we start working on our first proposal on October 7th, and actually we get down the first draft by October 19th, and on October 23rd we finish it and we submit our proposal on October 24th. And this week we started working on prototype, and we are hopefully getting down to the final prototype and connect that to the actual hardware devices by the end of the semester, and then we will start doing more development to the final project.
We could possibly run into problems during the development of our application. We could have late delivery of the hardware, which could hold back a lot of testing. We could have communication between the hardware and server not going correctly. We could, because we have to somehow get them all connected to a network, and for a car that could be an issue. We could have a group mate drop out of our capstone project, whether it's medical or if they graduate early. The code could get lost potentially, and that would set us back a lot. The functionality at the end when we finally deliver it could be not up to specification that we hoped for, and compatibility between platforms could be an issue between Android and the Internet devices and other things such as that. The impact of these, so if we could have the delay of the project delivery dates, we could have the project derail entirely if we have a severe thing. We could have increased workload and push back features or a loss of features. We could have a lower quality deliverable or limit our user base. So some risk mitigation is we can mock the hardware with the software until it's delivered, and that will hopefully prevent hardware from being pushed out too far. We could review the specifications immensely before we even get the hardware to make sure everything's okay. Stay in contact with our members and plan accordingly if someone has to leave or is sick. We'll use Git as version control, which will take care of a lot of code being lost or any issues with that. We'll be able to communicate expectations with our sponsors so we don't fall short of our specifications, and we'll be able to review the specifications of the server and hardware and make sure those can get together well. These are some of the references we used.